All right, the next thing you should be able to do for the final exam is fill in a chart with the subatomic particles. So remember, there are three main subatomic particles in the atom. We have the proton and the neutron, which reside in the nucleus, and we have the electrons, which are outside of the nucleus. Remember, the neutron has 0 charge and a mass of 1. The proton has a +1 charge and a mass of 1. The electron has a -1 charge and essentially no mass. So the atomic number is the number of protons. The atomic mass is the protons plus the neutrons. So all the mass of the atom basically is made up of the protons and neutrons. And if you take the protons and subtract the charge, you'll get a number of electrons. So remember, an atom can be neutral, meaning there's no charge, which means it has the same number of electrons as protons. Or it can be an ion, which means it's charged. So if it has a positive charge, it has more protons and electrons, and it's a cation. If it has a negative charge, it has more electrons and it has protons, and it's an anion. So let's go through filling out a table like this. This is something you should be able to do. I think most of you are pretty good at it already. But let's look through this part of your handout. So if we're trying to fill in a table like this, if we know the element's name, then we can just find it on the periodic table, and that will give us its atomic number. And in this case, phosphorus is element number 15. And what makes an element the element it is the number of protons it has. So phosphorus always has 15 protons. So if the atomic number and the number of protons are going to be equal. So the atomic mass is the mass of the atom of this isotope. So don't get confused and try to use the atomic masses off the periodic table, because those are the averages of all the different isotopes. So when you're filling in a table like this, just use the information that's within the table itself. So the mass of 31 is the number of protons plus neutrons. So if I take 31 minus 15, that leaves me with 16 neutrons in this case. This is a neutral atom, so that means the number of protons equal the number of electrons. So there has to be 15 electrons in this case. So that's how we'd fill in that row. So with the next row, we don't know what element it is, but we know how many protons it has. So we're going to look on the periodic table and see which element is number 35, which the number of protons equal the atomic number, so we could fill that in. And when we look, we'll see that element 35 is chlorine. So this would be chlorine, right? And then we can go on to finding the number of neutrons, because we know the mass is 80. 35 of that mass is from protons, so the remaining 45 has to be from neutrons. In this case, we have 36 electrons and only 35 protons, so we have one more negative charge than positive charge. So this is an anion. It has a -1 charge on it. If we move on to the next column, we see that the element is titanium. We go to the periodic table, we find titanium, and it's element number 22, so that's its atomic number and the number of protons. All right, so we're missing something here. This 28 should actually be over here. All right, so we can find its mass. The mass is the mass of the protons plus the neutrons, so we add those together and we get 50. And we see that we have a +4 charge. So that means we have 4 more protons than we have electrons. We have 4 more positive charges than negative charges. So that means we can only have 18 electrons. And that would be how you fill out a table like this. All right, the next thing on the handout is assigning oxidation numbers. So remember, when we assign oxidation numbers, that doesn't really mean that's the charge that element has. It's the charge it would have if it were an ionic compound. So it's kind of the prelude to doing oxidation reduction reactions, knowing what kind of oxidation state would be on any specific element within a compound. So here's like just a brief abbreviation of the rules we use for assigning them. You can go back to the lecture and get all the rules, but in general, hydrogen is going to have a +1 unless it's a hydride, which means it's attached to a metal. So we won't have to worry about hydrides here. Oxygen, you're going to assume it's a -2 unless it's a peroxide, and we won't see any peroxides. Any element by itself that doesn't have a charge is neutral, right? So it has a 0 charge. In an ionic compound, whichever the elements have whatever charge they would normally have, right? So if you have something like sodium chloride, which is ionic, sodium would form a +1 because it's in group 1, chlorine would form a -1. And fluorine is always going to have a -1 charge. So if we look at assigning these oxidation numbers, if we have something like O2, that's an elemental compound, so the oxidation number we would assign would be 0. There's no charge going on there. Now if we go on to something like MnO2, we'd kind of look at our rules and see, well, are there any things that apply? And here we see that oxygen normally has a -2 charge. So in the sum of the oxidation numbers have to equal the charge on the compound, so we don't write it here, but there's a 0 charge. So the oxidation number we assign to the manganese has to equal the total oxidation assigned to the oxygen. So we have 1 manganese and we have 2 oxygen that we're going to give them a -2 charge. So we're getting a -4 there. Here we're trying to calculate what that charge is going to be, but they have to equal 0. So our manganese has to equal 4 to offset this -4. So our charge on manganese is going to be +4, and our charge on oxygen is going to be -2. So those are the oxidation states. We have 2 oxygen, each of them with a -2, and our manganese is going to have a +4 charge. All right, so if we move on to the next one, here we have a negative charge, so we're going to try to sum to a -1 instead of 0. And we're going to do the same process here. Manganese, we don't know what its charge is, but we're going to assign a -2 to our oxygen. So we have manganese with some charge that we're going to figure out, and we have 4 oxygens, each of them with a -2 charge. So we have a -8 charge, and we have a question mark here, but we're going to sum to a -1 instead of a 0. So the only thing that we can put here is a 7 minus 8 equals a -1. So our manganese we're going to say has a +7, and our oxygen is going to have a -2. So we have 4 -2s and 1 +7. That gives us a -1. So there's a couple ways to look at this problem. We could say, well, SO4 is a polyatomic ion with a -2 charge, and these hydrogen are each going to be +1 because we assign them a +1 up here. So you could kind of split it in 2, or else you could kind of put it all together. So hydrogen is going to be a +1, oxygen is going to be a -2. So we have a hydrogen with a +1, hydrogen with a +1, we have S with a question mark, and we have 4 oxygens with a -2, and we're trying to equal a 0 charge. So we have a -8, we have a question mark, and we have a +2, and this has to equal 0. So the only number that can go in here is a +6. So our hydrogen, we have 2 of those with a +1. Our sulfur has a +6, and all of our oxygen have a -2. And that's how we would have assigned oxidation numbers to sulfur, or to all the elements in these compounds. So here our oxygen is 0. Here the oxygen are -2. Manganese was a +4. Oxygen is -2, -2. Manganese in this case was a +7, and so forth.